the way to introduce myself, I'm from the other bureaucracy across the Atlantic, where the National Cancer Institute, where it's been, no disrespect, but it's more than just a political mission that we've had for some time within the NCI, but it's also very much a real scientific and social mission that we have within the Institute to address this disease. And I think we heard from this morning's meeting really a challenge and promise that these computational approaches we're really going to have in some of the more difficult diseases. And I think cancer is really one of the model diseases in that respect, in terms of as a disease of complexity. And I think we've seen that the impact that cancer has had across the world, not just within the U.S. and Europe, but also in other developing nations, a great impact. And it's been one that we haven't, as opposed to some of the other diseases, we haven't had as much of an impact as we've liked throughout the time. And this due to a number of reasons. And I think one of them that was highlighted also this morning is really cancer is a very complex disease. And probably that's why one of the reasons it's been chosen as the one that has the greatest could potentially have the greatest impact by the approaches that we're going to be discussing today and throughout the rest of this workshop. I don't want to go through the iteration of the various reasons why it's so complex, and I think everybody in this room understands and appreciates that, but with the fact that it is one of the challenging things that we face. And one of the reasons that we have this sort of our dilemma is because I think partly because of our success in terms of, we also heard this morning, in terms of as our population is aging with an age disease, that we're seeing more and more cases while we've had some success in some of the death rates due to cancer. We've also seen an increase in the incidence of cancer, and it's due to a number of reasons, both in terms of as the disease progresses, as we generate an increasing population of patients who have been treated and cured of the disease, but become a high-risk population. And then also just because of the changing nature of this. And a lot of the therapies that we've addressed and have put great promise in really are very specialized trainings that have some very much limited. And that's one of the reasons why we've looked to this approach to try to understand, and more importantly to understand, but to manage the disease. So I think the goals of this workshop are straightforward, and this was laid out by both Tom and Georgios, is that we're really trying to highlight the role of in silico modeling and understanding the complexities of the disease. We're going to hear to discuss the common challenges and opportunities, and really not just the approaches, but in translating those approaches of modeling approaches into clinical practice. I think we also have this opportunity in this transatlantic workshop really to identify and facilitate interactions and collaboration. So I'm hoping that we'll see a lot of that too as we go along, as we recognize the work of each other. I was also asked to comment on a meeting that we recently had in the area of systems biology. It's really very much linked to these approaches. And we also heard this morning about how that's linked and where we really need, when we start looking at the systematic level, at the higher level of the various interactions that we see in the process of cancer, we're going to need these types of modeling and computational approaches to really now take it from the reductionist level to the systematic level. So we had a workshop organized by the EC and the NCI, Patrick Kohler and Fred Marcus, who were some of the coordinators for that meeting. And we had a number of, in May of this year here, well, not in Brussels, it was it was in Belgium, that's as far as I can tell. It was co-chaired by Rudy Abersol and Boris Zavitosky from the EC, and then from the U.S., Lee Hood and Mark Vidal. And it was a quite productive meeting, a 1.5 day meeting, where we really discussed the various approaches using a systems biology approach. And a number of, in treating cancer, we had a number of good discussions and conclusions that we came out of that meeting. And one was the understanding, somewhat obvious, that the systems biology and computational approaches can make important contributions in the treatment, and that we saw demonstrations of that, and I think we'll hear much more about that as we go through today. And another conclusion from that was that really that databases are going to play a central role in cancer research, and we really have to have the resources to maintain those as we start doing some of these high throughput analysis and getting a lot of the information in ways. And I would add to this not just databases in terms of data itself, but databases of models also, and be able to sort of promote and be able to exchange and facilitate that. And it's involved in all stages of cancer research, too, that modeling can have an input. And I think that there was also, I think it was clearly demonstrated that a number of analytical mathematical models that have been developed throughout the time really have relevancy in clinical practice today and to be able to be used. And so we're looking forward to pushing that forward. And I think that's one of the critical agendas that we'll be discussing today. So I think that meeting was very productive in looking at a systems biology as a whole and trying to understand how modeling is a critical aspect of that also. And I just want to sort of emphasize a little bit about what we're doing in the United States, at NCI specifically, and we have a program that's Tom's part of, and his center has helped sponsor this meeting, and that's the Integrative Cancer Biology Program, which is the theme of that is really combining both the systems biology and computational modeling together to try to understand the information that we see and to put that information using both of these approaches in sort of an iterative way to gain new knowledge and insight into the various cancer processes. And that's been ongoing now for 4 years. We've had a great success with that program. We're planning a reissuance of that. And just to quickly, as a way of sort of advertisement here, and I think we heard from the commissioner today too, this morning of how that the NCI or the NIH has recently redefined in terms of outside the U.S. involvement in NIH grants, and NIH has always been willing to fund researchers outside the U.S. and it was just been more standardized now, and I think the EC has also loosened up their regulations too. So it's really, I think some of these international collaborations are going to become more of a reality now as we go along. And just we're going to be reissuing the Integrative Cancer Biology Program as Centers of Cancer Systems Biology. We're also going to see linked R1. So these things will be coming out, and I just want to make everyone aware of those as we go along. And just closing with an interesting quote here from Rutherford Harris, who is a great modeler in and of himself. And it's kind of a chicken and an egg thing. I know modeling has always had has a tough road to hoe in terms of getting acceptance in not only in biology, but especially in clinical biology. And it's interesting with this quote where, normally we're looking at a set of mathematical equations that describe a prototype, where here he sort of flipped it around, and one could say that the prototype is a model of the equation. And so I think as we try to go through this and to validate some of the approaches and models that we take, it's fair to look at this in a different perspective of where we're trying to say it's really the model really is a representation of this. And as we sort of try to make these more relevant, I think it's important to always pay attention to the biology. And it's one thing that we've stressed continuously is that sort of feedback to be able to take the model with its prototype and vice versa. So again, I think as Ilias had said, I think we have a great agenda for this meeting. I think it's the center point of this meeting as a whole in terms of demonstration of what modeling can do and the approaches in a disease that very badly needs this approach. And so again, I'd like to thank everybody and I look forward to a great meeting.